Hello everybody and welcome to week 11 statistics where we're talking about Z-scores. Now recall first, standard deviation was how far the scores were spread around the mean. On average, how far was each score above or below the mean, which I mentioned was like just the average distance of the scores from the mean. And the larger the standard deviation, the greater the spread of the scores. Now Z-scores are going to relate to standard deviation and mean. There's a Z-score formula we'll talk about soon, and it's all about the standard deviation and mean. Let's just look at an example first. Look at this example. Maybe I scored 72 in a maths exam and I scored 72 in English exam. So it seems like I did just as well in each. But really that's not true. It could have been a very hard maths exam, a very easy English exam, who knows. But here's some more data about it. The mean of the class. These are class data. So say the mean of the class got 60 in maths and the mean of the class got 60 in English. That still backs up that I did, just as well in both. And it says I did well in both because I got 12 marks above the mean. That's pretty awesome. Now let's look at the next bit of data we've got, the standard deviation of the data. The standard deviation of the class in maths was 12. That means it was really normal. It was really common for students to get marks 12 above the mean and 12 below the mean. That makes me feel not as good about myself because I got 12 above the mean. And a standard deviation 12 says, well, that was pretty normal. Just don't get too big ahead. Well done, but it was a bit normal. Look at the next one though. The standard deviation in the English class test was only 4. That means that the average was 60. And okay, it was pretty normal to get 1 standard deviation above the mean. It was pretty normal to get 64. That's what the standard deviation means. It was normal to get 4 away from the mean. So a mark of 56. So here's the mean of 60. A mark of 56 was pretty normal. A mark of 64 was pretty normal because the standard deviation was 4. I've just gone +4 and -4. Now, when we get further away from that, it gets less and less likely. If I go down another standard deviation to 52, that's 2 standard deviations away from the mean, under the mean. That's getting pretty unlikely, okay? That's getting really far away from the mean. In the same way that if I went up another standard deviation of 68, 2 standard deviations above the mean, that's getting pretty rare. Imagine how rare it is. Well, we'll look at the proper number soon, but to get 3 standard deviations away from the mean. So to get -4, so 48 is getting really, really unusual. That's a long way under the mean. And to go up another 4 here, 72, that's 3 standard deviations away from the mean. Again, that's getting really unusual. What that's saying is I did exceptionally well in English. Even though it looked like I did pretty normal. I got 72 in both, the mean was 60 in both, but really I got a normal sort of good mark in maths. I got a really exceptional mark in English. Another way to express this is, I'll just delete that. If I was graphing these things, here's, I'll just check that there's not a graph on the next page. Okay, there isn't, so I better, that's going to be some sort of, very bit dodgy. Here's what I'm graphing here is how the class did. Not me, how the class did. A mean of 60, so maybe that's, it's going up. Here's 0, 10, 20, 30, 40, 50, 60, 70, 80. So what was that? 10, 20, 30, 40, 50, 60, 70, 80. Where did most of the marks lie? Well, for maths, yes, the mean was 60. So I've got a lot of marks around 60. And the standard deviation was 12, so it was still really common. It was a bit, maybe it looked like that. That, within 12, there was still a lot of scores in there. But let's look at English. So that's maths. If I do English now, its mean was still 60, but its standard deviation was only 4. Maybe it looks like that. Okay, so that most of the scores, here's English, they've got the same peak, but in English, the data was much tighter. So maybe it was normal to get 4 above and 4 below, but it started getting really rare. So that's what they'd look like. Hopefully I've got some better pictures later. Not that we're going to be sketching like this. But that's the concept, that maths and English had the same peak, but English was tall and skinny with not much variation, and maths was shorter and fatter with a lot of spread on it. Okay, so as we're seeing, a small standard deviation means the scores are clustered together. That's what I've done with English. The scores are very, very close to this mean. And a large standard deviation means they were much further from the mean. Okay. So what I did was I scored one standard deviation above the mean in maths. One leap of 12 above the mean. 60 plus 12 is 72. That's exactly what I did. In English, I scored 3 standard deviations above the mean. The standard deviation is 4, and I scored 3 leaps of 4 above the mean to get to 72. So that's why I'm saying that English was like really, really impressive. Now, we've got to quantify that, and that's going to be quantified more next week when we talk about what percent of students would we expect to perform so well, you know. Weeks 11 and 12 are very intertwined. But at the moment, we're just going to talk about Z-scores. Now, I might be jumping ahead a bit. We're about to do it. But what I'm going to say is one standard deviation above the mean. Soon we're going to describe that is a Z of 1. What does a Z-score of 1 mean? It means I scored one standard deviation above the mean. And a Z-score of 1 is good because it's above average. A Z-score of 0 means I scored nothing away from the mean. So if someone, remember these little silly pictures I've drawn here of the whole class. If, say, Bob got the same, and let's just talk about in maths. Say in maths, Bob got a mark of 60, that means his Z-score is 0. He's no standard deviations away from the mean. He got the mean. But let's say Chris got, I've already done that one. Say Chris got 48. What's 48 compared to the mean and standard deviation? 48 is one leap of 12 below the mean. That means Chris got a Z-score of -1. So literally, when you quote a Z-score, you're just saying how many standard deviations you were above or below the mean. I got, in this one, I'm pretending that it was me that got it, 3 standard deviations above the mean. I got a Z equals 3. And what's a better Z-score? Well, just think of it on the number line. A Z-score of 0 means I got the mean. Z-score of 1 is fantastic, 1 standard deviation above the mean. Z-score of 2 is even better. Z-score of 3 is even better. Z-score of -1, I got 1 standard deviation below the mean. -2, -3. So the higher the number, the more to the right on a number plane, the better the Z-score is. A Z-score of -1 is better than a Z-score of -2. So I'm closer to the right. Okay? It's a higher mark. So let's look at example 2. Again, this will come together. Well, I really hope so, obviously. Here's some test marks. Test A got all of these results. Test B got all of these results. From the calculator, test A, apparently its mean was 13 with a standard deviation of 2. Rightio. Test B had a lesser mean of 10 and a standard deviation of 3. So be it. So for test A, 19, the whole question, I should have read the question first. The marks from 2 tests are shown below. In which test would a result of 19 be a better mark? If we look at 19, the mark of 19 compared to, well, here's test A. And here's test B, and we'll just summarise. Test A, the class had a mean of 13. Test B, class had a mean of 10. Here's that little lower case sigma, which was standard deviation. Sigma was 2 for test A and was 3 for test B. So here's my little summary. Yep. So say I got 19. Well, it's above average in both tests. So it's a good mark either way, you know. But how many standard deviations is it above the mean in test A? Well, for test A, what would the Z-score be? A Z-score of 1 would be 13 would be 15. Plus 2 would be 17, plus 2 would be 19. That's a Z-score of 3. In test A, I got a Z-score of 3. That's huge, you know, that's 3 standard deviations above the mean. That's really, really, really well done. It's a positive 3. I don't have to write the plus there, but it is. What about in test B? 1 standard deviation above the mean would be 3 above 10, which would be 13. 2 standard deviations would be another 3, which would be 16. 3 would be another 3, which would be 19. I actually did the same in both. in both scenarios, I got a Z score of 3. So a score of 19 was just as good in both tests. In both cases, I was 3 standard deviations above the mean. Okay, so here's where the formula comes in. I've just done it manually there, but we've got a formula that we can use, and it's a formula that's provided on our cheat sheet. And it says that the Z score, the Z is just representing Z score, equals X is the score that we're discussing, minus, remember X bar was mean, over, remember that little sigma was standard deviation. So the Z score is a score minus mean over standard deviation. Let's check that on the previous example. Okay, if Z score is score minus mean over standard deviation, this Z score for test A, and I'll just put a little a there, the score we're talking about is 19, minus the mean of the test was 13, over a standard deviation was 2, 9 minus 13, well that's 6 over 2, which is 3. Yeah, you bet that formula calculates the Z-score for me. All it does is find out how far above the mean the score was by getting my score and taking the mean off it. So it says I was 6 above the mean. Then it says, well, how many standard deviations is that? So you divide 6 divided by the standard deviation, said there were 3. Perfect. And what if I did it for B? Well, I'd say the score we were discussing was still 19, minus a mean of 10, over a standard deviation of 3. So that gave me a 9 on 3, which, yep, sure enough, so that formula will do my work for me. That formula is going to be of even more use later because Z-scores don't have to be a whole number. I'm only using them as a whole number, but you can have a Z-score of 1.2, which is a bit better than 1. You can have a Z-score of 2.685, you know, all sorts of decimals. So, we've got a formula now, and that's what we just checked. So let's look at example 3. Now, I like to separate these. Here's Jack's mark in a mathematics and chemistry test. Jack got 66 in maths and 60 in chemistry. And despite what some of us might do, we can't judge him for those marks unless we know what the average and standard deviation was from the class. I mean, we can still say, good on you, you passed both. You know, let's not be all PC about this. We can't judge how well he did compared to himself or compared to others until we know his Z-score. So let's look at the class. Like I said, I like to separate. This is the class data, and on the left is just Jack's data. Now, you can see here, for mathematics, what's his Z-score? Well, the score he got was 66, so that's why it goes here. Let's subtract the mean from it. The mean was 55. So we get a 66 minus 55, which is 11, divided by a standard deviation of 10. 11 on 10 is 1.1. So that says, on the number plane, you know, say these were Z-scores, minus 1, 1, 2. He got a Z-score of 1.1 for maths. That's pretty good. Even naught, average is good. Anything above naught is even better. Okay, so in maths he got 1.1. Now what do you get in chemistry? Well, his score was a 60. Take off the mean from chemistry, which is a 50, so that's a 10. But it's divided by an 8. And 10 on 8 is a 1.25. That's just that little bit better. His maths was 1.1, but his chemistry was 1.25. So he did really well in both, yeah, but his chemistry was a bit higher because his Z-score was that bit bigger. Let's check another. Example 4. Harry scored 62, so let's like to write out the data. Harry scored 62, in which, so there's Harry and here's the class, in which the mean for the class was 50 and the standard deviation was 8. What was that, English? He also sat a maths test in which the mean was 60 and the standard deviation was 5. What mark would he have to have had achieved in maths for his performance to be equivalent to that in English? So I've got a bit of unknown, so I'm glad I've got a formula and hopefully a little bit of algebra skills. We want this performance to be just as good as this performance. And we know the performance is judged by what Z-score did you get. We want equal Z-scores. Equal performance means equal Z-scores. So first let's calculate the Z-score for English. It's happening off to our left as well. But my Z-score for English would be the score he got, 62, minus the mean score, which is 50, divided by the standard deviation of 8, which is 12 on 8, which is 1.5. So he got a z-score of 1.5. Excellent stuff in English. We want the z-score for maths to be the same. So let's look at my formula for the z-score for maths. The z-score for maths is equal to, well, it's still score minus mean over standard deviation. In this case, I know what z-score for maths I want. I want 1.5. I don't know what score he needs to get. X is still unknown. Do I know the mean maths mark? I do. The mean is 60. And the standard deviation of maths mark was 5. There it is. Now I've got to do some algebra. I've got this divided by 5 on the right that I don't want. So let's do the opposite, but divide by 5 by timesing both sides by 5. 1/2 times 5 is 7.5 equals, and that divide by 5 on the left has just totally disappeared because we times by 5. The only thing I've got left to do is to get that x by itself. I've got to add a 60 to both sides to get rid of the minus 60. So you can see if I've got x equals 7.5 plus 60, that's x equals 67.5. That's the mark I need in order to get the z-score that I want in maths, the 1.5 that I was after. Great, okay. It seems a bit quick. I want to do, okay. I want to do more. What was it I was talking about? Okay, just some little examples. I'll try not to nick these ones, but just some little concepts. Jimmy got a z-score in a subject of -2, and Mary got a z-score in some subject of 0.1. Who did better? Now remember, it's not just the magnitude. Picture the number line. A z-score of 2 is up there, but a z-score of -2 is down here. Jimmy sits down here. Mary's z-score was 0.1, so she's sitting right about here. So 0.1 is not a big number, but it's more positive than -2. It's more to the right on the number line. Jimmy actually got 2 standard deviations below the mean. Mary got a little bit above. 0.1 might not look too impressive, but it is. It's above average compared to below average. So remember the plus minus in z-scores? Yeah, you want to be more to the right on the number line. Are there any examples here that, okay, that's very similar. That's exactly the same as what I've been doing. Okay, and there's a bit of stuff that's combined in the previous weeks. Okay, this is what I just wanted to do. I just want to be able to grab something like this. When the numbers aren't as pretty. Question 11, I'll just grab 11D. I don't know why. For some reason it's standing out a bit. It's got an extra space in there, so it's getting picked on. What's question 11? The scores on a physics test have a mean of 53.1 and a standard deviation. I admit, I normally write SD because my sigmas are just so, it's sort of like that, you know, they're shocking. But whether you write SD or sigma, we know it's a standard deviation. Determine the z-score for a score of 70.5. Well, look, there's no difference here except the numbers look nasty. This may not be a clean jump of 8.7s up from 53.1. I really don't care. We've got a formula. As soon as it said determine the z-score, I know that the z-score of any situation is the score we're discussing minus the mean divided by the standard deviation. The score we're discussing is a score of 70.5. The mean is this 53.1 and the standard deviation is 8.7. I'm not going to go through many hoops here. I'm just going to do it on the calc. So it's a 70.5 minus a 53.1, which is equal to, so I got, or he got, whoever we're talking about, a 17.4 marks above the average. Very impressive. Divided by 8.7, we can see, actually it is nice. The numbers didn't seem nice, but it came out a whole number 2. But even if the answer was 2.3843, I would call it 2.38 to 2 decimal places, or 2.4 to 1 decimal place. So z-scores can be unattractive, not whole, but that's all good. Honestly, that's z-scores. It seems it's not enough content for a week. I do think weeks 11 and 12 should be put together, but they haven't been yet. So enjoy. And if z-scores comes to make sense, week 12 is just going to add a bit to that, and it'll make even more sense, I reckon. Okay, bye-bye.